Good morning, everyone. You can please put your attendance here. Okay, so I think my screen is shared, right? Yeah. So our point of discussion is industrial media, right? Production of industrial medium. And in our last class, we also told what could be the requirement for industrial medium, right? We pointed out. So basically today we will go a little bit faster. It will not be so slow discussion today. So first requirement for whenever I'm going for any industrial media preparation for any microbial growth, I need to have some qualities. First quality, it should support growth and product formation. That means it should have the nutrient, it should have the required material, microelement, macroelement, which can support the growth of the microorganism and possibly it can improve product formation. I already told you in our last class, if I know the product, what is the composition of product, carbon, nitrogen, hydrogen, oxygen, if I know appropriate amount, so for example, C and N5HO3, like that. So if I know the carbon nitrogen ratio of the product, sometime we can decide what could be the ideal substrate for my microorganism, choice of microorganism. That means product and biomass. I also told that biomass also has a composition. If you remember in our last class meeting, so maybe carbon 1.4, nitrogen 2, hydrogen 12, and O3, for example. I'm talking about microorganism. Each microorganism has a different composition. You cannot really tell it beforehand, but some average composition we can always find out. So basically, microorganism composition is there. This is also there. And I know my substrate composition, glucose, definitely I know. And for example, urea, I know. So basically, if I know this is my substrate and this is my product, this is my biomass, I can always put a balance equation, right? You can always make a, like chemistry, make a balance, na? NaOH plus HCl, you make a chemically balance equation. Here also balance is possible. If I know how much of glucose I should take or how much of urea I should take, so that I will have this much of biomass and this much of biomass or this much of product, we can always do. So balancing equation is also one of the strategy to know whether it is fine or not. Your media should support the growth. It should be supporting product formation. Second requirement, I already talked in our last class. It should not be costly. Okay, it should be easily available and always reproducible. What I mean by that? Reproducible means many times, if you do not have any quality control, if I ask you to bring sugar and you purchase the sugar from 5 different shops, I'm sure the sugar will be different in terms of their clarity, in terms of their crystal size, they're all different. But when we are going for industrial production, any media or formulation we are looking for, the production should be always reproducible. That means I should have the same quality of the products, the raw material for fermentation process. That is required. We should maintain it. We should have a source to get it. That is very, very important when we are looking for industrial process. for production of important valuable metabolites. And third one, the media must not be too much viscous. Viscosity should not be high enough. Many times we can find out, for example, starch. Starch is a very good substrate, but many times if I use starch, the medium becomes too viscous. And if your fermentation media is too viscous, you know, right? You have definitely seen pudding kind of things. If it is too thick, do you think putting a agitation will be sufficient to mix oxygen transfer? Nutrient transfer will be very difficult. So it should not be viscous, too viscous, so that you cannot really handle it when you are going for a fermentation process. The last one for industrial fermentation process is that it should be, in most of the time, it should be having quality for long-term storage and sterilization. That is very, very important. Long-term storage means because we are keeping the media, maybe most of the time in our lab, we'll keep it in a dry conditions, keeping away from moisture. Okay, that is fine. We can keep it long time. That is very important requirement. And sterilization of media is always there. Whether I'm doing in a lab scale, small or large scale, this quality must be ensured when I'm looking for a media composition. So cost, support of growth and product, operating conditions, and stability and storage. These are the very primary requirement for industrial fermentation process. Now, the first question anyone will have that, okay, what are the different kinds of media we can have? So today I'll be talking just few more time on this. What are the different kinds of media are possible? The first one is synthetic or chemically defined medium. And second one is known as complex medium. What are they? Synthetic means you are actually telling me the composition. So for example, you are telling, sir, I want to prepare a media where glucose will be 10 gram per liter, for example. Disodium hydrogen phosphate, for example, 3 gram per liter. For example, you are saying that calcium chloride 0.1 gram per liter, ammonium nitrate 2 gram per liter. You see why we are choosing like this? I understand glucose is the source of carbon. Calcium is a one element required. Chloride ion, ammonium nitrogen source, nitrate nitrogen source, disodium hydrogen phosphate, phosphorus is there. You see, that means we are designing, we are taking some ingredients which one will support for carbon, another is supporting for phosphorus, another is supporting for nitrogen. Oxygen is always there, hydrogen is always there in most of the cases, so you need not worry about those things. So carbon, nitrogen, phosphorus is already there. If you think that your microorganism is producing some enzyme, okay, so containing sulfur, okay, it is having sulfur containing enzymes, for example, they are going to produce, and then I must have something on sulfate. So for example, ferric ammonium sulfate we are using, okay, or ferric sulfate, ferrous sulfate or ferric sulfate, Fe3 you can also have. So basically, I know the carbon, I know the nitrogen, I know the calcium, I know nitrogen sources, I know iron, I know sulfur. Basically, if we prepare a media by blending those components, just a second please. Hello. So basically, carbon, nitrogen, phosphorus, sulfur, these ingredients we are prescribing. And if we do this, this is called chemically defined medium. Chemically defined medium. Am I clear? because each component is known formula. I know exactly what is their formula, and I know how much is there in this medium is called chemically defined. Chemically defined media is good for one reason. What is the reason? You can control. So for example, you are using a media, synthetic media, you are growing some microorganism, it is growing, for example. And if you think that, okay, I want to increase a little bit more, so you may add a little bit more glucose, because if you think that glucose is the shortage, you can add more glucose. So that means you have a very fine control. You can manipulate the composition as per your need, and you can adjust. This is one way. And this kind of media is known as chemically defined medium. Try to understand, in many of the lab, we prepare a chemically defined medium for, 1 second please again. Anmu sir? Professor, I am in a class. Can I talk to you later? Yes. So basically, these kind of media are mostly used in laboratory. When I'm asking some students to isolate some microorganism and grow some new strain, I will try to go for this kind of media. Why? Because I'm having the freedom to manipulate. I can add little more glucose, I can put less ammonium nitrate, I can do a different recipe, right? Because I know these things I will use, but composition I will change. So I can have many recipes, and I can prepare different media, and possibly I can find out, okay, this composition is giving more product, something like that. We can decide. Instead of glucose also, for example, you are not using glucose, okay, you are using fructose, galactose, or some other carbohydrate. You may use some starch if you want, okay, dextrine you can use, dextran you can use. So basically different kinds of polymer, monomer, carbon source, that is your choice, you can actually include in these kinds of synthetic or chemically defined medium. Problem is that it is most time it is costly, because I have to purchase pure glucose, I have to purchase ammonium phosphate, sodium dihydrogen phosphate, ammonium nitrate. These ingredients we have to purchase, and they come with some price tag, right? And so that's why it will be one problem for industry. Industry what likes? Industry do not like these kinds of media, because they have to mix so many things. Rather than in our lab also we have many complex media. Let me tell you, we have nutrient broth. Probably if you are studying your microbiology part, okay, nutrient broth also has a composition. I don't definitely memorize all the composition of each of the media, but essentially I know I can have peptone, beef extract, yeast extract. What are these? These are actually source of animal proteins. Okay, we are having peptone, beef extract, yeast extract. We will add salt also. For example, NaCl. Not only peptone and beef extract are not only for protein source, they can also serve some amount of carbon source. Complex nitrogen, complex carbon is there. So it is actually like you are taking some food in your lunch time. So you are taking so many things are mixed. It is very difficult. If I ask you, can you tell me how much exactly glucose is there or how much calcium chloride is there? You cannot do. But what happens? As this is a complex medium, we do not identify each of the carbon source, each of the nitrogen source, each of the calcium, magnesium, iron, no. But fortunately, they mostly contain each of the elements also, carbon, nitrogen, phosphorus, everything will be there, because they are originated from plant or animal origin. It is product from plant or animals, right? And we are going to use those things, these kinds of media, which are actually chemically undefined. And why I am telling complex? Because we do not know their exact proportion, how much of what compound is there. But basically overall, they fulfill the requirement for carbon, nitrogen, phosphorus, all those things are fulfilled. Of course, they also have a composition. For example, how much peptone, how much beef extract, how much yeast extract, how much NaCl should we use, composition is there. So basically, these kinds of media where you cannot identify the compound individually, chemical formula you cannot write, these are often called as complex media. Now, what is the purpose of using complex media? Why should we use? There is some point. Definitely, there is definitely some important point. The first important point is that most of the time, whatever we are harvesting from plant source, animal source, they do not have exact formula. For example, I am having some canola oil, mustard oil. Okay, we are collecting from, or rapeseed oils, we are collecting from different plant sources. Do you think the oil composition is always constant? No. I am growing some seed somewhere else, someone is growing somewhere in another state. Do you think the same oil composition will be same, exactly same? Unsaturated fatty acid will be exactly same amount, 20.5% like that? No. That means these complex media are from plant or animal source. There will be some variations. So try to understand, complex media is beautiful because I need not know each of them. I'll get together many of the things. If I'm taking some oil, do you think it is only contain carbon, hydrogen like that? Not necessarily. Of course, they contain higher amount of fatty acid composition is there, but not necessarily only fatty acid. It will have carbon source, nitrogen source. It can support nitrogen compound requirement for plant or animal or any complex medium. So complex medium is good because they are from plant animal source. We need not really mix, but the problem is also there. Industry like them, but there is a problem. The first problem is that it is not reproducible, but industry need that. Industry need the reproducibility. Every time, every batch should be similar composition. So that can be one challenge when we are people, industry is looking for complex medium use. Of course, they are not going for industrial process, peptone or yeast extract like that. But most of the other ingredients, they will try to support from complex medium. They can fortify, add something other ingredients for better production. So you got the point? So these are the two kinds of media we'll be talking about when we are coming into preparation of media for fermentation process. All of the media should have the desirable property. We can be able to autoclave, we can able to sterilize, it should be giving growth to microorganism. These things are very important. And as the time is going up and we are understanding the more detailed about the medium formulation, we are also focusing more on what should be the ratio. Even people also try to manipulate the peptone, beef extract, yeast extract proportion so that we can have better growth for some kind of microorganism. Media should also be, another purpose of the media is also there in microbiology particularly. The media should also support, preferentially support the growth of your desired microorganism. What I mean by that? Many times in these are called actually selective media. It is microbiology part, not from fermentation process. There can be some medium where we can actually adjust the carbon source. We can adjust. For example, I know some microorganism can actually degrade and grow on starch. So for them, I will give starch. But if I give starch for everyone, do you think all microorganisms will grow there? No. So they should have the enzyme system. The microorganism should be able to degrade, utilize that substrate. It is very important. Even if they have the same amount of carbon, some carbon substrate may not be useful at all. For example, I am telling glucose, it is also a carbohydrate, starch, carbohydrate, pectin, of course there. You understand my point of discussion? And lignin, these are all components from carbohydrate based material. Carbon source is there always. But do you think that if I use some lignin or pectin, your microorganism can utilize them? Of course not, very difficult. Because structurally they are different, even if they are all carbohydrate. Starch, everyone can utilize? No. Glucose, most probably. So you need to also understand what kind of substrate we should have in a defined media. Similarly, when I'm making a complex media also, we may have some ingredients we are also adding, which will only allow the growth of your desired microorganism, and other unwanted microorganisms in our atmosphere are there, right? They should not be allowed. So that means they will not be able to take it up. They will not be able to grow. Maybe we can have manipulation of pH. I can reduce or increase the pH. So many microorganisms will simply go away. They cannot survive. So your media should be preferentially useful by your target microorganism, or it should have some selection. These media are called selective. And you need to understand, even if I am having two media, glucose and starch, they will not give same amount of biomass growth. They will not give same amount of product. The product will be different, even if they can utilize both of them. So it is very important, not only the carbon source, what is the carbon source I am using is also really very important. It is very important how much. For example, if I use oil or if I use glucose, many times, many kinds of vegetable oils are used for production of biopolymers. If I do with glucose and if I do with oil, same gram basis, if I look for gram per gram, I may, or we are likely to get more production from oil rather than glucose. Why you think like that? Because many times the oil is composed of or consisting of linear chain of fatty acids. So one linear chain of fatty acids are already there. Okay, fatty acid, because this is a, for example, unsaturated or saturated, mostly it will be unsaturated chain only. So if it is there, so this is called fatty acid. Acid will of course have COOH, no SO. So this kind of fatty acid chain is already there in your oil. These kinds of fatty acid chain can be easily metabolized, and for example, my production is also some polymer. The polymer is, for example, a long chain alkylanoid, so alkyl polymers. So for example, I'm having this kind of polymer structure. You see, this structure is actually very much useful backbone for your product. Try to understand. So what is happening? This is actually a precursor which is required in the metabolism to produce something, and my substrate is actually already giving you some 50% job is done, because my substrate structure is really matching with that. So microorganism, without doing any manipulation, they can do. If I am giving glucose, what will happen? So in metabolism there will be assembly process. So simple linear chain of glucose, they should first make some precursor molecule. They will make little bit longer chain through your central metabolism, right? If you study metabolism, you will understand those processes. So they will have produced the fatty acid from glucose itself. So they will have to invest some process to make it like this, and then this will be coming into the metabolic process. So basically, my summary of this point is that sometimes some of the substrate can be more useful, more productive for a given product formation, because they may be more closer in a metabolic pathway to your target product. So basically, microorganism need not do much of the step. It is already prepared, right? It is very easy to assemble. Metabolism is like that only. So your substrate can define your productivity. Same gram amount, oil can give you more production for some of the products we are looking for in a fermentation process. So this is very, very important aspects, selection of the substrate. Next point, what I am going to say is that sometimes the substrate we are going to use, okay, I'll come to it. Oh, sorry, I'll have another slide, then I'll come there. Sometimes not only this aspect, another aspects are also involved. Okay, another use is that if it is very easily available substrate, not good for secondary metabolite formation. What I mean to say, for example, one of the most easily usable substrate is glucose. Very good. So, for example, I am using glucose for production of some antibiotic by Penicillium species. What happens? Most of the Penicillium, this is a fungi, right? Not bacteria, fungi. So glucose will be utilized, fungi will grow biomass, and after some time, once they have sufficiently grown, they will use again glucose for production of their antibiotics. Antibiotic is a secondary metabolite. Primary metabolite means during the growth phase they are producing something. Secondary means they are all grown, okay? They are now retired, and then they will take the glucose and produce those things. So this is metabolism is not for growth. Their growth is over. So this metabolism is known as secondary metabolism, where the substrate is utilized for producing something which is not directly utilized for microbial biomass. This is not there. So secondary metabolite time, if I use glucose, there is a problem. The first problem is that glucose is very good substrate. What will happen? All the champions will finish up the glucose very quickly. They will use it up and finish and grow. After growth, when the all biomass has increased, the biomass finds there is no more glucose there because they are using glucose very fast. So if substrate is utilized very fast, very easy, then primarily they will go for growing only because this is very easy job. Once if they utilize, if they're growing so much on glucose, possibility is that they will finish up the glucose, media will be exhausted. Then what is the concern? Concern is that time there is so high biomass is present that there is no more substrate for production of its secondary metabolites. Quickly finishing off, producing biomass, no product. This is not a good idea. We can use some other substrate, for example, lactose. It is slowly utilized. It is not as easy for glucose. So lactose will be consumed very slowly. Then what will happen? Biomass production is not very high. It is moderate. But the biomass, as when it is utilizing lactose, they will also do the secondary metabolism to produce your products. This is one example only I am telling, glucose, lactose, these kind of things. So I can have a substrate which is giving good growth. You need to understand, good growth substrate, not good for product, particularly if it is secondary metabolites. So this concept must be always there when we are looking for some sorts of media formulations. When you are going to look for what substrate we should use in fermentation process, these concerns will be there. Now, for some time, I will go to your textbook also. The reason for moving into textbook is that this is actually a theoretical discussion. There is no numerical aspects on that. So very likely that we may miss some of the concept, and it is full of examples. So some examples may be really important for you. So I'll just go through so that you can quickly, my screen is definitely shared, I believe. Yes, now coming into textbook. So here I am discussing, first of all, what is the media I should have, right? What should be the purpose of the media? I should always have a consistent quality. I will highlight so that you can always remember these points. Okay, it should produce maximum yield for product. This is very important aspects for the medium. It should have very little problem during sterilization. These are the all requirement. Okay, so this thing you always understand what can be the possible reason. And it is more easy because it should not be very viscous. So extraction, agitation, these things should be easily manageable. Okay. Now you see, we use many types of substrate we are using. Some of them are okay. I need to tell you also. There are some other important sources, particularly waste material in industry normally use. I will talk them later, not now. One of them is beet molasses, sugarcane molasses. What is molasses? Molasses is actually when, for example, if you know the production of sugar, okay, from sugarcane, what happens? They will have the extract, right? Extracted juice is there, and if you heat it up, it will be a concentrated syrup, right? And from the concentrated syrup, if you go for making it precipitation, high saturated, super saturated solution is there. We are removing up, apart from sucrose, removing the other impurities, and we are going for crystallization, recrystallization, and we will find the white crystals. This is sugar we normally use, white sugar we normally say. apart from that, if I am having different kinds of these, not necessarily from cane juice, we are having different kinds of maybe plant resources material rich in fructose. Okay, these kinds of material, if we heat it up, we can always find a thick browny liquid remaining, and that is called molasses. Molasses is also good rich nutrient. Even we can also utilize as a human being also, we have the molasses. Actually we call it jaggery. It is a similar variant of molasses. That means it is, apart from the sucrose component, all other ingredients from the extract we are going to get, particularly for example sugarcane production. So sugarcane industry, if I am going to have the extraction, the juice remaining portion is going to form a thick sediment kind of things, brownish liquid. This is very important source for fermentation process because they have very easily usable sugars. Okay, so they can have part of sucrose also is there, fructose will also be available. These things are widely used. So some example I can take and talk you about the cane molasses. Cane molasses means, the cane means you understand sugar cane. From that we are going to do beet molasses. Beet is also used for sugar production. Beet molasses can also be used. Cereal grains use, starch use, sucrose, lactose. These are all carbon sources. Nitrogen sources is used for corn strip liquor. Corn is actually a rich source of nitrogen also as well as. So corn strip liquor also, when you are using the corn for removing the cellulosic material, we will have particularly the lignin, lignocellulosic biomass will be there, and we are extracting it, and this thick black color liquor is also utilized, and this is a rich source of nitrogen. So corn strip liquor is also used as a nitrogen source in many industries, but you should be cautious because one industry producing corn strip liquor, one industry producing molasses, they will vary. So variation is always there, that you will please try to understand. They can be very cheap sources. Okay, however some other expensive pure substrate may be chosen if the cost is not so high. So if I am going to produce something, my product is too important, I'll get so much money, then I can use some pure substrate also. So these points are also there, which will decide what kind of media I'll be using. Other portion I have already talked about. It should be available, it should be influence the composition of the mediums, it should have optimum concentration, nitrogen, all those things for your production. So please go through this process. Viscosity is also important point I should highlight. In old days, most of the people use the complex medium, but actually complex medium had some problems because we cannot really control. So you need to be considered what kind of medium we should always choose, what kind of products we should be always there. So we should always have some, when we are going for some specific purpose, we need to also consider those aspects always. And so this is the basic theory, what is the introduction part. Here, as I told you, I can have some carbon, I will have some nitrogen, I will have oxygen, I will have other nutrients. I will try to have, if I'm really going to make the understanding of the process, you always try to have for equation, and stoichiometry can be useful. So biomass, product, carbon dioxide, water, heat, these are the product. What is the source? I'm having carbon substrate, nitrogen, oxygen, other requirement may be nutrient. So if it is possible, if we can really do, so we can actually quantify how much biomass will be produced, but it is definitely not really easy because many times we do not have the very clarity on the composition of biomass, what are the contents you have. So if you have, then you can use for calculate the concentration necessary to produce product yield. So we can do the calculation if we have the knowledge of the stoichiometric part. What are the ingredients we are using that we are talking about for growth of microorganism elements composition? What can be the trace element? As I was telling, iron, zinc, copper, manganese, cobalt, molybdenum, boron, these things. Mostly I will use these things in our trace elemental solution. When you do in lab, same thing may be required. But if I'm using complex media, I don't need them because complex means we are harvesting some plant or animal. They will definitely have those ingredients. So it is more easy for anyone. You see, there is giving so many examples for some of the fermentation medium. You see, cane molasses. What is the purpose? Sugar, right? Then I'm using some zinc, copper. Fine. So that means cane molasses itself is not a pure compound. It will also have some other ingredient. So if I'm having those specific requirement fulfilled, then we can skip. You see, this is using for etanoic acid. There is lots. You really need not tell you each of an individual components. Here you see glucose monohydrate, magnesium sulfate, ammonium phosphate, potassium dihydrogen phosphate, iron, manganese, zinc, copper, corn strip liquor. Why? Because they feel that nitrogen source is not so high, so they are fulfilling with corn strip liquor. So other components are defined. So this is actually semi-synthetic. Semi-synthetic means 50% of the components possibly I am giving individually, and something I am giving as a complex substrate. Few example of the complex substrate can be, for example, as I am telling, corn strip liquor, nitrogen source, molasses, okay, whey. Whey is what is whey? Whey is actually when I am going to, for example, removing the proteinous material from milk, right? So, like in this process, we are acidifying the milk, right? If I acidify the milk, what will happen? So, casein, milk protein will separate out. You already know what is the purpose and use of this, right? And the remaining watery content, okay, the remaining light yellow to brown color watery liquid, what is that? That is called whey. What does it contain? It is a very rich source of carbon source. It is also fulfilling some amount of nitrogen. Of course, we are removing the nitrogen. So whey is also one of the industrially relevant waste. This is actually a waste, but we should try to utilize, industry try to utilize them very effectively. These are the, for example, defined media. These are defined media we can have. Molasses, complex media, soy flour, complex, but other components are defined. So basically, this example you need not memorize at all. My point of discussion is that we can have different composition, different constituents can be there in this production, and we need to understand each of the purpose. You see, the media can vary, carbon, hydrogen, nitrogen, phosphorus, sulfur, all those compounds can be taken care. This part I already told, I need not speak. That is called yield. I need to know what is your substrate, how much is product is formed. You understand? How much of product is formed, how much of substrate consumed, that is going to give you yield. So I would like to take, or we would like to take such kind of media which will give us more yield coefficients. Different substrate can have different yield coefficient. You see, I am having, for example, I am using maltase, acetate, glucose, ethanol, methanol. If my microorganism is able to utilize all of them, I am finding the cellular yield coefficient, how much biomass is produced. You see, they all produces different amount. So definitely, if my purpose is to grow my biomass, I will take N alkanes, normal alkanes, which is producing more biomass compared to any all the compounds till now we have discussed. Compared to acetate, my ethanol is better. So you need to understand that when I am choosing some substrate, what is my purpose, I can decide what kind of substrate can be chosen. And those things can essentially be done if you can make a stoichiometric of this biosynthetic pathway. That means if I know what is my biomass, what is substrate, what is nitrogen, oxygen, where sulfuric acid, for example, we are using here, for example, precursor, my product, carbon dioxide, water. What is this thing? I am not using biomass perfectly here because this is a secondary metabolite. So possibly I need not really bother about biomass growth. Are you trying to understand? I told you, if it is secondary metabolites, then biomass is not produced. Biomass is already there. They will use the substrate and produce the product. So basically, you see, this example is talking about penicillin production. You see, I'm having glucose, ammonium source, oxygen, sulfur source, producing the penicillin G. So if I know somehow, if I can make a balance of this equation, it is very easy for us to predict how much glucose will be required. And for biomass, if I'm going to produce some biomass production, if it's still involved, for example, then you can also use it. If I am having biomass production, then I will use biomass equation, but there is no fixed biomass equation available till date. So I need to understand what product we are looking for, what yield value is there, and if I know the equation, it will be always easy for anyone to find out what could be the compositions of nutrients. So other major nutrients which will be required is definitely oxygen, but we are really not considering. So primarily we will be focusing on carbon source, energy source, nitrogen, water, trace element. We will be speaking. In our next class, we will be talking about carbon and nitrogen source in more great details. That means I will try to highlight few carbon sources. What should be the choice? What is my choice? Which carbon source I will utilize? This is very, very important to everyone. First, if I ask you simply, if you are going to now come into microbiology lab from the next day itself, what could be the guideline? What carbon source should you use? You will have to ask yourself many things. Many questions should come into your mind. First of all, what is the purpose? What we are going to do with that? If I say you, okay, I'm going to produce, for example, some metabolites, and we know the metabolite can be different things. Some acids can be there. It can be secondary metabolites, like maybe, for example, plant metabolite. You can also have ginseng, or maybe, for example, we are going to produce a metabolite like, for example, antibiotics. So if I know that what is our target, what is the product, I can be more decisive on choosing that. How much biomass we need? Do you need high much of biomass growth? If needed, then my substrate should be a little bit more easy. Is it easily available? Always people will try to use glucose, but still glucose you should not use always. There is many reasons. If I use glucose, it is easily oxidized microbial process, and they produce high amount of carbon dioxide also, aerobic metabolism. Large amount of carbon dioxide means it will reduce the pH. Many times if I am using glucose containing media, the media pH will be fall. It will become acidic. So you need to understand whether it is allowed or not. Okay. So cost of the media, what is the product, who is the microorganism, how I am going to sterilize. Glucose, if I autoclave, it will be gone. But if I use starch, no problem. It is not going to char, at least in autoclaving process. So many other carbon sources you can actually put into this process. Second thing I already told you, remember, if it is a precursor, it is always good because the productivity will always increase. So yield coefficient of the substrate, availability of this compound, competing other substrates are there, easy of autoclaving, those considerations, those components will definitely come into deciding what kind of carbon source I can utilize. Another group will also come, that is the synthetic variant, like I was telling, right? So for example, beet molasses, sugarcane molasses, can I use them? Is there any problem? They have sometime problem also, because those molasses is a complex. They may contain some of the metals or heavy metal which may be toxic to a microorganism. It is there. So for example, I'm going with I'm giving this kind of substrate, complex substrate to a fungi. It may be problematic because maybe fungi cannot grow in presence of high concentration of copper, and copper may be there as a micronutrients in many of these complex media. So you should be careful what ingredients you can likely to have and what should be the choice in these kind of situations. So maybe not today, we will discuss it more detail on carbon sources. What are the factor? You see, glucose, glycerol, mostly glucose is widely used, so glucose will always be there. So it will definitely require what kind of carbon source I'm going to utilize. And use in lab and use in industry are different. Industry will do not try to use pure compound, as I told. They will always try to utilize some resources which is very easily, some byproduct, that is the industrial perspective. So anyway, we'll discuss more details on use of carbon sources, what kind of carbohydrate you see. We are using carbohydrate, we can use oil and fats. This is more widely used. Some hydrocarbon and derivatives can be also utilized primarily. So these things we will discuss in our next class. Okay, anyway, this is 45, time is over. And if you have any questions and queries, you please put into me.